Tonight, we are going to journey back to the very beginning, before the stars, before the galaxies, and even before time itself began to tick. We are going to explore the ultimate mystery of our existence. It is a question that has kept philosophers and scientists awake for thousands of years, yet tonight we will use it to help us find rest. The question is simply this: how did everything we know, all the vastness of the cosmos, arise from absolutely nothing? To understand this, we have to let go of our human perception of time and space. We have to travel back to a moment that was not really a moment at all, into a state of existence that defies our everyday logic. It is a journey into the deepest quiet imaginable. So, I invite you to get comfortable, to let the tension of the day fade away, and to let your imagination drift into the deep, velvet darkness of the primordial void. When we think of nothing, we usually picture empty space. Perhaps you imagine a dark room or the vast, silent gaps between the stars. We tend to think of nothingness as a passive stage, a blank canvas waiting for the paint of the universe to be applied. It feels intuitive to us that if you take a box and remove all the objects from it, you are left with an empty box. And if you could somehow pump out all the air, remove every single dust mote, and block out every photon of light, you would be left with a vacuum, a space containing nothing. But the universe, as it turns out, is far more strange and magical than that simple box. Over the last century, our understanding of the cosmos has shifted dramatically. We have learned that the concept of nothing is actually one of the most complex and active states in physics. There is no such thing as truly empty space. What we used to call a vacuum is actually a seething ocean of potential, a state of waiting, alive with hidden energy. Let us try to visualize this together. Imagine we are floating in the deepest reaches of space, far away from the light of any galaxy. It is darker than any night you have ever experienced. It is colder than any winter. To our eyes, it looks like a perfect void. It looks peaceful, static, and empty. But if we could tune our vision to the quantum level, if we could zoom in billions upon billions of times past the scale of atoms, past the scale of the protons and neutrons, down to the very fabric of space-time itself, we would see something startling. We would see that the void is breathing. In the world of quantum mechanics, which rules the very small, there is a fundamental rule that forbids absolute stillness. It is known as the Heisenberg uncertainty principle. Put simply, nature refuses to be pinned down completely. You cannot know the exact position and the exact energy of a particle for a set period of time with perfect precision. This creates a loophole in reality, a sort of fuzziness in the laws of physics. It means that even in a perfect vacuum, where there should be zero energy, the energy value can fluctuate. It can jitter. Because of this uncertainty, empty space is constantly bubbling with what physicists call virtual particles. These are ghostly pairs of particles, one matter, one antimatter, that pop into existence out of nowhere. They borrow a tiny amount of energy from the vacuum, exist for a fleeting fraction of a second, and then collide and annihilate each other, returning that energy back to the void. It is a ceaseless, shimmering dance, a constant sparkle of creation and destruction happening everywhere, all the time, in every cubic centimeter of the universe. Right now, in the empty space in front of you, this invisible foam is bubbling away. It is happening in the space between the stars, and it happened in the epoch before the universe began. This tells us something profound. Nothing is unstable. The void wants to become something. So, when we ask how the universe started from nothing, we are not talking about a magical appearance of objects out of a blank void. We are talking about a transition, a shift from a quantum nothingness, which was rich with potential and energy fields, into the physical something that we inhabit today. But this brings us to a difficult hurdle. Where did the energy come from? We are taught in school that energy cannot be created or destroyed, only changed from one form to another. This is the law of conservation of energy. It seems to suggest that you cannot get a universe for free. If you want to build a galaxy, you need the materials. If you want to light a star, you need the fuel. Creating a universe filled with billions of galaxies should, by rights, require an infinite amount of energy. Who paid that bill? The answer is one of the most beautiful concepts in modern cosmology. It is the idea of the zero-energy universe. Let's think about gravity. Gravity is an attractive force. When you hold a stone and drop it, it falls faster and faster. As it falls, it gains energy of motion. But where did that energy of motion come from? It came from the gravitational field. In physics, we often classify gravitational energy as negative energy. It is like a debt. To pull the stone back up against gravity, you have to put work in. You have to pay energy back. Now, consider the universe. On one side of the ledger, you have all the positive energy, the mass of the stars, the heat of the gas clouds, the light and the motion of the galaxies. It is a tremendous amount of positive energy. But on the other side of the ledger, you have the force of gravity pulling everything together. That is negative energy. Remarkably, when astronomers and physicists measure the total amount of matter in the cosmos and compare it with the strength of gravity, the two numbers appear to cancel each other out almost perfectly. The positive energy of matter is exactly balanced by the negative energy of gravity. The sum of the universe is zero. This is a calming thought. It means the universe did not require a massive injection of power to begin. It required a separation. It is like digging a hole in the ground to build a hill. You take the dirt out of the hole, that is the negative space, and you pile it up to make a hill. That is the positive stuff. If you add the dirt in the hill back into the hole, you are left with flat ground again. You are left with zero. The universe is simply the hill and the hole. It is a ripple in the nothingness. It suggests that our existence is the ultimate free lunch. We are a fluctuation that grew large. Before that fluctuation grew, however, we have to consider the seed, the thing that started it all. We often call this the singularity, or the initial state. But words fail us here because we are trying to describe a state where our current laws of physics break down. Imagine shrinking the entire observable universe, every galaxy, every nebula, every black hole, running the clock backward. The galaxies rush together, the temperature rises, the vast distances of space collapse. Eventually, everything we see is compressed into a point smaller than a proton, smaller even than that. At this scale, the distinction between space and time blurs. In our daily lives, we move through space and we move through time. They feel distinct. But deep in the quantum foam of the beginning, space and time were likely a chaotic, mangled foam. Some theorists suggest that time as we know it did not even exist yet. Asking what happened before the Big Bang might be like asking what is north of the North Pole. There is no north. There is no before. There is just that timeless state of quantum potential. Drifting in this timeless state, we can imagine a scalar field. This is a concept similar to a magnetic field, or the temperature in a room, a value that exists at every point in space. In the very early universe, there was a specific field, often called the inflaton field. You can think of it like a ball resting on top of a hill. As long as the ball sits perfectly balanced on the peak of the hill, nothing happens. It has potential energy. It could roll down, but for the moment, it is still. The universe is in a state of false vacuum. It is stable but precarious. It holds a tremendous amount of energy locked up in that field, waiting to be released. In the deep silence of the pre-universe, this field permeated the tiny, microscopic seed of space. It was a high-energy state, tense and ready. It was not matter. It was not radiation. It was just a property of space itself, a pent-up breath held for an eternity. And then, something slipped. Perhaps it was a random quantum fluctuation, a tiny jitter in the field that nudged the ball from the top of the hill. The field began to roll down. As it rolled, the energy that was locked inside it began to change. It is this moment, the moment the ball starts to roll, that triggers the event we call the Big Bang. But before the explosion of fire and light that we are familiar with, there was a mechanism that had to clear the stage. This mechanism is the key to why the universe is so big and smooth today. It is called cosmic inflation. We will explore inflation fully in the next leg of our journey, but for now, let us focus on the conditions that made it possible. We are sitting in a bubble of space that is incredibly small. It is far smaller than an atom. It is hot, but not with heat as we know it. Hot with potential. It is smooth, but rippling with those tiny quantum jitters. It is difficult to comprehend how small this seed was. If you were to take a single proton and look at the quarks inside it, you would still be looking at something gigantic compared to the initial seed of the universe. And yet, encoded in that speck was the blueprint for everything. The slight variations in density in that quantum foam, the tiny differences where the energy was slightly higher here or slightly lower there, those are the reasons we are here. If the nothingness had been perfectly smooth, perfectly uniform, the universe would have remained a boring, featureless soup. Gravity would have pulled everything equally in all directions, and nothing would have clumped together. There would be no stars, no planets, and no us. We owe our existence to the imperfection of the void. We are the children of the jitter. This concept redefines how we feel about emptiness. In our modern lives, we often fear silence. We fear the empty calendar, the quiet room, the pause in the conversation. We feel the need to fill every moment with noise and activity. But the story of the universe tells us that the void is not a lack of something. It is the source of everything. The void is a pregnant silence. It is the deep breath before the song begins. So, as we lie here contemplating the dark, we can take comfort in the fact that we are connected to this primordial state. The atoms in your body, the light from your bedside lamp, the gravity holding you to the bed, all of it is just a borrowed fluctuation from that ancient quantum ocean. We are, in a very real sense, just a complicated form of nothingness. We have now set the stage. We have a tiny, microscopic speck of space filled with a dense, high-energy field, trembling with quantum uncertainty. It is suspended in a state of timelessness, with no outside, no inside, just a singular point of existence. The ball is tipping. The energy is about to be unleashed. The silence is about to be broken by the loudest event in history. But before that expansion begins, let us linger for just a moment longer in this perfect quiet. It is the last time the universe will be this simple. It is the last time it will be this unified. Soon, forces will separate. Gravity will break away. The strong and weak nuclear forces will take their corners. Electromagnetism will emerge. But for this fleeting instant, if we can even call it an instant, everything is one. There is a profound beauty in this unity. Scientists search for a grand unified theory that combines all the laws of physics into one simple equation. They are looking for the mathematical description of this exact moment. They are trying to write down the music of the silence. It is a state of balance, the positive and the negative, the matter and the gravity, the potential and the kinetic. Everything is poised on the edge of a knife, ready to tip into reality. We often wonder why there is something rather than nothing. Some physicists suggest that nothing is simply unstable, that a state of true, absolute nothingness is forbidden by the laws of quantum mechanics. If you try to have zero particles, zero fields, and zero space-time, the uncertainty principle says no. The probability of existence is greater than zero. Therefore, the universe had to happen. It was inevitable. This removes the burden of chance. It wasn't an accident that we are here. It was a requirement of the void. The universe is a mandatory manifestation of quantum laws. As we prepare to move forward in time, to witness the birth of space itself, we carry this knowledge with us. We are not intruders in this cosmos. We are not separate from the space that surrounds us. We are the ripples in the field. We are the echo of that first quantum fluctuation. The stage is set. The potential energy is peaking. The fabric of space-time is curled up tight, holding a tension that is capable of stretching to infinity. The clock is at zero. The darkness is absolute. And then, the field begins to drop. The vacuum energy, which has been repulsive, pushing outward with a pressure we can barely comprehend, is released. The tiny speck does not just expand, it explodes outward with a violence and a speed that makes the speed of light look like a standstill. We are about to enter the era of inflation. We are about to watch the universe grow from the size of a subatomic particle to the size of a grapefruit, and then far beyond, in less than a billionth of a trillionth of a second. The silence is ending. The great cosmic unfolding is about to begin. We are now standing at the very edge of the precipice. The ball of potential energy has tipped. The hesitation of the void is over. We are about to witness the most explosive, rapid, and transformative event in the history of the cosmos. It is an event so fast that the human mind struggles to frame it. Yet it is the reason the night sky looks the way it does. We call this moment cosmic inflation. To understand what happens next, we have to adjust our sense of scale once more. We are accustomed to things expanding into space. When a firework explodes, it sends sparks flying outward into the cool air around it. When a balloon inflates, it pushes into the room. But the expansion of the universe is fundamentally different. There is no room. There is no air outside. There is no outside at all. When inflation begins, it is space itself that wakes up. Imagine the universe at this moment as a sheet of elastic rubber, stretched infinitely tight, curled up into that tiny, subatomic speck we left in the darkness. As the inflaton field releases its energy, it acts like a reverse gravity. Instead of pulling things together, it pushes space apart with a ferocity that defies description. In a fraction of a second, a sliver of time so thin that a clock would not even register it had begun, the universe expands. It does not just grow, it doubles. And then it doubles again, and again, and again. The power of doubling is deceptive. If you take a step of 1 meter and then double it to 2 and then 4, it seems manageable. But if you double something 100 times, you cross the observable universe. Inflation is this exponential doubling, happening at a rate that makes the speed of light seem like a snail crawling across a continent. You might be pausing here wondering about a rule we all learn, that nothing can travel faster than the speed of light. This is one of Einstein's iron laws. But there is a loophole. Einstein said that no object can move through space faster than light. No rocket, no particle, no message can outrun a photon. But he did not say that space itself has a speed limit. Space is the stage. The objects are the actors. The actors cannot run across the stage faster than light, but the stage manager can stretch the stage as fast as they like. During inflation, the fabric of the cosmos stretched so violently that 2 points which were touching a moment ago were ripped apart faster than a beam of light could bridge the gap between them. Let us try to visualize this silent explosion. Picture a grid, like a sheet of graph paper glowing faintly in the dark. This is the fabric of space-time. Suddenly, the grid lines begin to fly apart. The squares of the graph paper grow immense. What was once a tiny, intimate neighborhood of quantum fluctuations is torn asunder. This expansion is cold. It is hollow. Because space is stretching so fast, any stray particles that might have popped into existence are diluted instantly. They are lost in the widening gulfs. The universe becomes a vast, cold, empty mansion, expanding in silence. It is a moment of profound loneliness. But this expansion solves a mystery that you can see with your own eyes every night. If you look at the sky in the northern hemisphere and then travel to the southern hemisphere and look at the sky there, the universe looks remarkably the same. The distribution of galaxies, the temperature of the background radiation, the density of stars, it is all uniform. This should be surprising. These two sides of the sky are separated by billions of light years. They have never touched. They have never exchanged a phone call or a beam of light. How do they know to be at the same temperature? It is like finding a cup of coffee in London and a cup of coffee in Sydney that are the exact same temperature down to the millionth of a degree. You would assume they were poured from the same pot. Inflation tells us that they were poured from the same pot. Before the expansion started, everything was touching. That tiny speck we envisioned was intimately connected. The temperature was balanced. The density was even. Then, inflation took that tiny, balanced speck and blew it up to the size of the cosmos faster than the coffee could cool down. The uniformity of our night sky is a fossil. It is the stretched-out memory of that initial microscopic unity. As the universe unfurls, something magical happens to those quantum jitters we spoke of earlier. Remember the bubbling foam of the void? The uncertainty? The tiny fluctuations where energy was slightly higher or slightly lower. Normally, those fluctuations appear and disappear in a blink. They are temporary ghosts, but inflation is too fast for them. It catches them in the act. As space stretches, it grabs these tiny quantum ripples and stretches them out. It takes a subatomic wobble and stretches it until it is the size of a galaxy. This is the magic microscope of inflation. It takes the smallest things in nature and writes them large across the sky. The slight unevenness in the density of the universe today, the fact that we have clusters of galaxies here and empty voids there, is simply the magnified print of those quantum fluctuations. If space had not stretched so fast, those ripples would have vanished. Instead, they were frozen in place, locked into the fabric of the universe as a blueprint. We are flying through this expanding dark, watching the grid lines race away to infinity. The universe has grown from a proton to the size of a grapefruit, and then to the size of a city, and then the size of a galaxy, all in less than a billionth of a trillionth of a trillionth of a second. It is a concept of time that has no meaning to our biological clocks. This period also explains the flatness of the universe. When cosmologists talk about the universe being flat, they do not mean it is two-dimensional like a pancake. They mean that parallel lines stay parallel. If you shine two laser beams into the dark, they will stay the same distance apart forever, never meeting, never diverging. If the universe had started out curved or warped, inflation fixed it. Imagine a balloon that is wrinkled and crinkled. Now, imagine blowing that balloon up until it is the size of the Earth. If you were an ant standing on that balloon, the surface would look perfectly flat. You would walk for 1,000 lifetimes and never notice the curve because the expansion has smoothed it out. Inflation stretched the fabric of space so tight that any initial curvature was ironed flat. It prepared a perfect, smooth, level table for the feast of matter that was to come. But this ride cannot last forever. The energy driving this expansion, the inflaton field, is rolling down its hill and it is approaching the bottom. The false vacuum is about to decay. The free lunch is over and the bill is coming due. We are approaching the moment of reheating. This is a misleading name because the universe was not hot before this. It was cold and empty due to the rapid stretching. Reheating is the moment the universe truly catches fire. Think of a car braking at high speed. The kinetic energy of the car has to go somewhere. It goes into the brakes, turning into heat. The brake pads glow red hot. Or think of water falling over a dam. The potential energy of the water at the top turns into the kinetic energy of the fall, and when it hits the bottom, it churns and boils. The inflaton field crashes to the bottom of its energy valley. It starts to oscillate, sloshing back and forth like a ball settling in a bowl. As it sloshes, it decays. That massive reservoir of energy that fueled the expansion has to go somewhere. It cannot just disappear. It dumps its energy into the fields of standard physics. It pours its power into the electromagnetic field, the quark field, the electron field. Suddenly, the cold, empty, expanding void is filled. The energy transforms into particles. Quarks, electrons, neutrinos, and photons flood the cosmos. The vacuum dies, and the material universe is born. This is the hot Big Bang as we typically imagine it. Many people think the Big Bang was the start of the expansion, but it is perhaps more accurate to say the Big Bang was the moment the expansion slowed down and the fire began. It was the moment the universe stopped being a mathematical abstraction of expanding space and became a physical reality of hot plasma. The temperature skyrockets. We go from absolute zero to trillions of degrees in an instant. The universe is now a soup. It is dense, searingly hot, and filled with a chaotic swarm of particles colliding with one another at near-light speeds. The inflation has stopped. The exponential, doubling growth is over. The universe is still expanding, coasting on the momentum of that initial kick, but gravity is now beginning to wake up and tap the brakes. The wild ride is finished, and the long, slow evolution of the cosmos can begin. Let us pause here and appreciate the scale of what just happened. We have gone from a speck of nothingness to a hot, dense fireball of vast proportions. We have taken the quantum uncertainty of the microscopic world and painted it across a canvas billions of miles wide. We have set the initial conditions for everything that will ever happen, every star that will ever shine, every planet that will ever form, every atom in your body. The potential for all of them was delivered in this brief, silent pulse of expansion. The stage has been built. The lights have been turned on. The actors have been thrown onto the stage. But the universe at this moment would be unrecognizable to us. There are no atoms yet. It is too hot for them to hold together. There are no protons or neutrons, only the raw constituents, the quarks and gluons, swimming in a sea of radiation. It is a universe of pure chaos. It is also a universe of intense conflict. As the energy condensed into matter, it also created antimatter. For every particle of matter created, a twin particle of antimatter should have been born. Matter and antimatter are enemies. When they touch, they annihilate instantly, turning back into pure energy. By all rights, the newborn universe should have destroyed itself immediately. The matter and antimatter should have collided, annihilated, and left nothing behind but a bath of dull radiation. The universe should have ended before it truly began, and yet it didn't. You are here. The stars are here. Something happened in that blindingly hot soup to tip the scales in favor of existence. A tiny imbalance, a slight preference for matter over antimatter, allowed a fraction of the material to survive the great annihilation. As we prepare to dive into this primordial soup in the next chapter of our journey, hold on to the feeling of heat and density. We have left the cold, silent expansion behind. We are now in the inferno. We are in the era where the forces of nature are separating, where the fundamental particles are fighting for survival, and where the first seeds of structure are beginning to coalesce in the blinding fog. The silence of inflation has been replaced by the roar of the primordial plasma. The universe is alive with energy. It is opaque, glowing, and incredibly dense. It is a time of transformation where the rules of the game are being written in fire. So let us rest for a moment in the afterglow of inflation. The universe is vast now. It is no longer a speck. It is a world of possibility. The nothing we started with has successfully transformed into something. But this something is raw and unformed. It is a clay that needs to be fired. We have witnessed the miracle of the stretch. Now we must witness the miracle of survival. The grand experiment of the cosmos is underway, and the outcome is anything but certain. We are now immersed in the aftermath of the great inflation. We have arrived in a universe that has stopped its frantic, exponential stretching and has settled into a state of burning, crushing reality. If we could exist here, suspended in this primordial epoch, we would not see stars. We would not see the black velvet of space. We would see only a blinding, suffocating brilliance. We have entered the era of the primordial particle soup. It is difficult to convey the intensity of this moment. The universe is now filled with a plasma so hot and so dense that the laws of physics, as we experience them in our daily lives, are pushed to their breaking point. Imagine a fog, but a fog made not of water droplets, but of pure light and raw energy. This fog is so thick that you could not see your hand in front of your face. Light is trapped, bouncing frantically from particle to particle, unable to travel in a straight line. In this blinding soup, the temperature is measured in trillions of degrees. It is a heat so intense that it prevents matter from taking any familiar form. There are no atoms here. If an atom tried to form, if a proton tried to capture an electron, The sheer violence of the ambient heat would smash them apart instantly. Even the nuclei of atoms, the hard centers of protons and neutrons, cannot exist yet. Instead, we are looking at a state of matter called the quark-gluon plasma. Quarks are the fundamental building blocks of reality. In the world we know today, they are shy creatures. They are always found bound tightly together in groups of 3 to make protons and neutrons. They are glued together by particles appropriately named gluons. In our cold, modern universe, you can never find a quark alone. Nature forbids it. If you try to pull 2 quarks apart, the energy you put into pulling them actually creates 2 new quarks to bridge the gap. They are prisoners of their own attraction. But here, in the first millionth of a second after the beginning, the rules are different. The heat is so extreme, the energy so high, that the quarks are free. They roam the universe like a swarm of angry bees zipping through the plasma, colliding, interacting, and moving with a liberty they will never experience again. It is a soup of fundamental ingredients stirred by the violent hand of temperature. Drifting through this soup alongside the quarks are the leptons, particles like the electron and the neutrino. They too are caught in the crush, battered by photons of light that are energetic enough to turn into matter and back again. This is a key feature of this era, the interchangeability of matter and energy. Einstein's famous equation, E=mc², tells us that energy and mass are 2 sides of the same coin. In our quiet lives, we rarely see this conversion happen. You cannot turn a battery's energy into a rock, but in the thermal bath of the early universe, this conversion is happening everywhere, all the time. 2 photons of light smash together and create an electron and an anti-electron. A moment later, those 2 particles crash back into each other and dissolve back into light. The universe is breathing matter in and out. It is a shimmering, shifting equilibrium where existence is fluid. But as the clock ticks forward, still not yet reaching a full second, a dramatic tragedy begins to unfold. It is the great war between matter and antimatter. As we touched upon earlier, the laws of physics generally love symmetry. When energy turns into matter, it produces equal parts of matter and antimatter. Antimatter is the mirror image of the stuff we are made of. An anti-electron has a positive charge instead of a negative one. An anti-quark has the opposite properties of a quark. When the universe cooled just enough that the creation of these heavy particles slowed down, the annihilation began. Matter and antimatter are destined to destroy one another. When they touch, they vanish, releasing a burst of gamma radiation. Imagine the carnage of this moment. The universe is filled with these pairs, created from the pure energy of the Big Bang. Now, as the temperature drops, they begin to find each other. Trillions upon trillions of collisions occur every instant. It is a cosmic suicide pact. The vast majority of the substance of the universe is being erased before it can even coalesce into anything permanent. If the universe had been perfectly symmetrical, this would have been the end of the story. The matter and the antimatter would have paired off perfectly, 1 to 1, and annihilated each other completely. The universe would have been left as a sea of light, a bath of radiation, with no matter left to form stars, planets, or people. It would have been a beautiful, empty tomb of light. But we are here. The rock you stand on is here. The water you drink is here. This means the symmetry was broken. Somewhere in the deep, complex mathematics of the early universe, there was a tiny flaw, a slight preference. For every 1 billion particles of antimatter, the universe created 1 billion and 1 particles of matter. It is a ratio of survival so slim it seems impossible, yet it is the only reason we exist. As the great annihilation raged on, the billion pairs destroyed each other, turning back into pure light. The fog of the universe glowed brighter with their death throes, but that one solitary particle, the billionth and first survivor, was left alone. It had no partner to destroy it. It floated in the soup, a survivor of the Holocaust of the first second. You, and everything you see around you, are made of those leftovers. We are the tiny fraction of the universe that survived the Great Purge. We are the asymmetry. It is a humbling thought to realize that our existence is due to a microscopic imperfection in the laws of nature. As this war winds down, the universe continues to expand. The expansion is the master clock. As space gets bigger, the energy is spread out over a larger area, and the temperature drops. The universe is cooling. It is no longer the frantic, infinite heat of the first instant. It has cooled to a mere 10 billion degrees. We are now approaching the 1-second mark. At this cool temperature, a major structural change occurs. The quarks, those free-roaming travelers we watched earlier, begin to feel the chill. They can no longer move fast enough to escape the strong nuclear force. They become sticky. Suddenly, they begin to snap together. 3 quarks rush together and lock into place, bound by the gluons. Once they click together, they cannot escape. The era of the free quark is over forever. They have formed hadrons. The most common hadrons are the ones you know, protons and neutrons. This is the moment the nucleus of the atom is born. The universe is transforming from a soup of raw ingredients into a soup of cooked, distinct particles. It is still a plasma. The electrons are still running. Wild, but the heavy cores of matter have been forged. However, the universe is still a dangerous place for a neutron. A free neutron, one that isn't part of an atom, is unstable. If left alone, it will decay into a proton within about 15 minutes. The clock is ticking. The universe has to do something with these neutrons before they all fade away. If they all decay, we will be left with a universe of only protons, only hydrogen. There would be no complexity, no carbon, no oxygen, no life. We are now a few minutes into the life of the universe. The temperature has dropped to a distinct threshold. It is now cool enough for nuclear fusion to begin. This is the era of primordial nucleosynthesis. For a brief window of time, lasting only about 20 minutes, the entire universe acts like the core of a giant star. The protons and neutrons are slamming into each other with enough force to stick, but not so much force that they break apart again. A proton finds a neutron. They fuse to form deuterium, a heavy version of hydrogen. Then, another particle slams into them. They build up. They form helium. It is a frantic race against the cooling temperature. The universe is expanding so fast that the furnace is turning off. The density is dropping. The particles are finding it harder to find partners. It is like a game of musical chairs, where the chairs are flying apart from each other. In these frantic few minutes, the chemical composition of the cosmos is set in stone. About 75% of the matter remains as simple hydrogen protons. About 25% manages to fuse into helium. A tiny, tiny trace becomes lithium, and then the window closes. The temperature drops below the threshold for fusion. The nuclear fires go out. The universe falls silent in terms of nuclear reactions. The great factory of elements has shut down. It will be millions of years before a star is born to restart the process of creating heavier elements. For now, The universe is a simple mix of hydrogen, helium, and a dash of lithium, swimming in a sea of light and electrons. Let us take a moment to drift in this new environment. It has been perhaps 20 minutes since the beginning of time. The chaos of inflation is a distant memory. The war between matter and antimatter is over. The heavy lifting of creating the atomic nuclei is done. But the universe is still a trap. It is still opaque. If you were floating there, you would see nothing but a glowing white fog. This is because of the electrons. Protons and helium nuclei carry a positive electric charge. Electrons carry a negative charge. Naturally, they want to come together to form neutral atoms. But the universe is still too hot. It is still teeming with high-energy light particles, photons. Every time an electron tries to settle down into orbit around a photon slams into it and kicks it away. It is a state of constant frustration. The electrons are homeless, wandering through the gas, because these electrons are free. They act as a fog. Light cannot pass through a swarm of free electrons. The photons bounce off them like billiard balls. This means that information cannot travel. An image cannot form. The universe is glowing, but it is blind. It is a trapped fire. This state persists not for minutes and not for hours, but for thousands of years. We are entering a long, slow waiting period. The drama of the first second is replaced by the slow, steady breathing of expansion. The universe simply gets bigger and cooler, bigger and cooler. The roaring white noise of the beginning softens. The intense gamma rays stretch out into X-rays, and then into ultraviolet light. We are drifting through a glowing, dense mist that spans billions of light years. It is a time of suspension. The ingredients are there. The nuclei are ready. The electrons are waiting. But the heat is keeping them apart. It is like a love story where the two lovers are separated by a raging storm. They can see each other. They are drawn to each other. But the energy of the storm prevents them from holding hands. It is peaceful in a way, a vast, glowing uniformity. If you measured the density of the universe in one place and then measured it a million light years away, it would be almost exactly the same. But remember those tiny quantum fluctuations from the inflation era? The little ripples we stretched out? They are still there, hidden in the fog. In slightly denser regions, gravity is quietly beginning to do its work. It is pulling just a little bit harder on the surrounding gas. These regions are the seeds of future galaxies, but for now, they are just subtle shadows in the mist. They are the sleeping giants of the cosmos, waiting for the fog to clear so they can wake up and begin the work of building stars. This era of the primordial soup is the bridge between the initial spark and the structured universe we know. It is the era where the raw energy was tamed. It was tamed by cooling. It was tamed by expansion. We often think of the Big Bang as an explosion of matter. But looking at it this way, through the lens of the particle soup, we see it was really an explosion into matter. The energy froze into form. The light slowed down into mass. As we prepare to leave this section, imagine the vastness of this glowing plasma. It is no longer a grapefruit. It is already millions of light years across. It is a colossal, glowing cloud, expanding into the nothingness, carrying with it the precious cargo of protons and neutrons that will one day make up your heart, your brain, and the air you breathe. They are all there. Every atom of hydrogen in the water in your glass was born in those first few minutes. It has been traveling through time, changing form, participating in stars and nebulas. But the nucleus itself, the proton, is a relic of this exact moment. You are touching the primordial soup every time you take a sip of water. We are now ready for the next great phase change. The storm of light is about to break. The electrons are about to find their homes. The fog is about to lift. We are approaching the moment of first light, a moment that will reveal the universe in all its glory. But for now, let us rest in the warm, bright glow of the early cosmos, watching the slow dance of the particles as they wait for the temperature to drop just a little bit more. The universe is holding its breath, waiting for the clarity that is about to come. We have spent a long time in the fog. For nearly 400,000 years, the universe has been a trapped, glowing ocean of plasma. It has been a time of waiting, a time of slow, rhythmic breathing as the cosmos expanded and cooled, expanded and cooled. If we were drifting through this era, we would feel a sense of suspension, as if the universe were holding its breath, waiting for the fever to break. Now, we are approaching one of the most significant turning points in the history of existence. It is the moment the universe opens its eyes. Astronomers call this event recombination, but that is a dry, technical term for something that was essentially a moment of cosmic liberation. It was the moment the fog lifted and the first light was set free to travel across the deep. To understand why this moment is so beautiful, we must look at the color of the universe. In the earlier epochs we explored, the heat was so intense that the light was beyond the visible spectrum. It was gamma radiation and X-rays, invisible and deadly. But as the centuries turned into millennia, and the millennia piled up into hundreds of thousands of years, the expansion of space stretched that light. It stretched it into the ultraviolet, and then, finally, into the visible spectrum. The universe began to glow. At first, it was a blinding blue-white like the arc of a welder's torch. Then, as the temperature dropped further, it softened into a bright, piercing yellow, similar to the surface of our sun. And now, as we reach the critical threshold, the universe is bathed in a warm, intense orange. Imagine being inside a cloud that is glowing with the color of a peach or a setting sun. Everywhere you look, in every direction, there is only this warm, orange light. But despite this warmth, it is still a cage. We still cannot see anything. The photons of light are still trapped in their endless game of pinball, bouncing off the free electrons that swarm through the gas. The universe is bright, but it is opaque. It is a wall of fire that fills all of space. The temperature is now hovering around 3,000 degrees Celsius. This might sound incredibly hot compared to a summer day on Earth, but in cosmic terms, it is cool. It is the temperature of the filament in an old light bulb. And crucially, it is the temperature at which the frantic energy of the particles begins to calm down. For eons, the electrons have been trying to settle. They are negatively charged, and they feel the irresistible pull of the positively charged protons. They want to orbit them. They want to form stable hydrogen atoms. It is the most natural desire in physics, to balance the charge, to become neutral. But every time an electron has tried to slow down and circle a proton, a high-energy photon has slammed into it, kicking it back out into the void. It has been a frustrating dance of almost, but not quite. The thermal energy of the universe was just too high to allow atoms to exist. But now, the balance tips. The expansion of the universe has drained the light of its violent power. The photons have become weaker. They no longer pack enough punch to knock an electron out of orbit. Suddenly, across the entire vastness of the cosmos, the great capture begins. It does not happen in a single instant, but over a period of perhaps 100,000 years, a mere heartbeat in cosmic time. One by one, the electrons slow down. They spiral in toward the protons. They are caught by the electromagnetic force. They slip into stable orbits, and this time, when the photons hit them, the electrons stay put. They absorb the hit and hold their ground. The proton and the electron have finally married. They have formed neutral hydrogen. This change sweeps through the universe like a wave of silence. The free-roaming, chaotic charges disappear. The electric storms that have raged since the Big Bang vanish. The plasma, which was a wild soup of charged particles, transforms into a calm gas of neutral atoms. And in that transformation, the miracle occurs. Neutral atoms are almost transparent to light. Because the electrons are now locked away in their orbits, they are no longer blocking the path. The photons, which have been trapped in a dense traffic jam for nearly 400,000 years, suddenly find the road ahead is clear. The fog does not just lift, it vanishes. The walls of the cage dissolve. For the first time in history, a photon of light can travel in a straight line. It can move for a meter, then a kilometer, then 1,000,000 light years without hitting anything. The universe has become transparent. This moment is known as decoupling. The light and the matter, which have been locked in a tight embrace, separate forever. The matter is left to drift and follow the pull of gravity. The light is released to fly across the cosmos. Imagine the visual spectacle of this transition. You are floating in that glowing orange fog. Slowly, you begin to see depth. The wall of light starts to recede. You can see further and further. The glowing gas becomes translucent, revealing the vast, deep structures of the universe behind it. And then, the light passes you. The brilliant, peach-colored glow that filled the sky is released. It rushes past you, speeding away at 300,000 kilometers per second, embarking on a journey that will last for billions of years. This released light is what we call the cosmic microwave background. It is the afterglow of the Big Bang. It is the oldest light in the universe. When you look up at the night sky today between the stars, you see darkness. But if your eyes could see microwaves, if you had eyes like radio telescopes, you would not see darkness at all. You would see this light. You would see a faint, shimmering glow coming from every direction, filling the entire sky. That glow is the fossil of this exact moment. It is a ghost image of the universe, as it was when it was just 380,000 years old. It is a baby picture of the cosmos. When we capture this light with our satellites today, we are looking back across an ocean of time. We are seeing the very wall of fog that we just watched dissolve. We are seeing the surface of last scattering, the last place the light bounced before it was set free. There is something incredibly moving about the journey of these photons. Think of a single particle of light released during this great clearing. It flies through the newborn hydrogen gas. It travels for millions of years. It passes through the regions where galaxies will one day be born. But there is nothing there yet, only drifts of gas. It travels on. Billions of years pass. Stars ignite and die. Galaxies collide and merge. Earth forms from the dust of ancient suns. Dinosaurs rise and fall. Humans evolve, learn to make fire, learn to look up. And finally, after traveling for 13.8 billion years, that single photon falls into a radio dish on a remote mountain on Earth. It ends its journey as a tiny blip of data on a scientist's screen, telling us the story of its birth. Whatever static you might have seen on an old analog television set, that snow that danced on the screen when there was no channel, a tiny percentage of that static was caused by this light. The echo of the Big Bang has been dancing in our living rooms, unseen and unappreciated, for decades. But let us return to the moment of release. The universe is now transparent. The light is free. But something else is happening, something that will define the next great era of our history. As the light rushes away, the universe continues to expand, and as space expands, it stretches the waves of light traveling through it. This is the phenomenon known as redshift. The beautiful orange glow of the newborn universe does not last. As the millennia pass, the expansion pulls at the light waves, making them longer and looser. The orange deepens into a rich red. The red deepens into a dull crimson, and then the light stretches beyond what the human eye can see. It shifts into the infrared. To a human observer, the universe would appear to be fading. The bright, blinding glory of the plasma era is dimming. The lights are going out. We are drifting from a universe of blinding brilliance into a universe of darkness. This is not the darkness of a night sky filled with stars. This is a true, absolute dark. There are no stars yet. There are no galaxies. There is no source of light anywhere in the cosmos. The only light that existed, the afterglow of the Big Bang, has been stretched into invisibility. We are entering the Dark Ages. It is a time of profound silence. The violence of the beginning is over. The screaming heat is gone. The universe is a vast, expanding sea of hydrogen and helium gas, slowly cooling, slowly drifting in the dark. If you were to float there in that endless night, you would feel a deep, penetrating cold. The temperature is dropping toward absolute zero. There is no sound, for there is no air to carry it. And even if there were, there are no events to make a sound. No explosions, no collisions, no machinery of nature grinding away. Just the silent, relentless expansion of the dark. But in this darkness, the universe is not dead. It is pregnant with possibility. Remember those tiny seeds? The little fluctuations from the quantum era? The spots where the density was just a fraction higher than the surroundings? They are still there. They are hidden in the dark, invisible to the eye, but gravity knows they are there. Gravity is the patient sculptor of the dark. While the light flies away and the gas cools, gravity is working. It is very, very weak, but it is relentless. It never sleeps. It never stops pulling. In the pitch black, the gas is beginning to flow. Slowly, imperceptibly, the atoms of hydrogen are drifting toward those denser spots. A stream of gas here, a wisp of helium there. They are gathering. They are clumping. It is a process that takes millions of years. It is the slow accumulation of the raw material that will build the future. The universe is taking a deep breath, gathering its strength for the next great act of creation. There is a serene beauty in this emptiness. We often fear the dark, but in the cosmic story, the darkness is a necessary rest. The universe needed to cool down. It needed to stop being a chaotic plasma so that it could become a structured reality. It needed the quiet so that it could learn to build. The chaos of the collision of particles has been replaced by the gentle pull of gravity. The noise has been replaced by the flow. We are drifting through the largest ocean of time in the history of the universe, an ocean of shadows. As we move deeper into this era, we can imagine the scale of these gathering clouds. They are not like the clouds in our atmosphere. They are millions of light years across. They are vast reservoirs of potential waiting for the spark that will ignite them. The universe is currently a simple place. It has lost the complexity of the high-energy particle zoo. It is just gas and dark matter. But simple does not mean boring. Simple means pure. It is a blank canvas, primed and ready for the first brushstroke of starlight. We have traveled a long way from the quantum void. We have seen the fire, the inflation, the war of the particles, and the great clearing of the fog. Now we find ourselves in the quietest moment of all. It is the calm before the dawn. Somewhere in the deep, crushing dark, the gas is getting thicker. The atoms are being squeezed closer together. The temperature in the centers of these clouds is beginning to rise again, not from the Big Bang this time, but from the pressure of gravity. The universe is trying to remember how to be hot. It is trying to remember how to shine. We are waiting for the first star. We are waiting for the cosmic dawn. But for now, let us drift in the velvet comfort of the dark ages. Let the silence wrap around you. There is no rush. The universe has all the time it needs. It is patient, it is vast, and it is preparing to light up the dark in a way that will change everything. We are now drifting through the longest, deepest night in the history of the universe. The brilliant fire of the Big Bang has faded into memory, stretched out into invisible infrared waves. The cosmos is vast, cold, and profoundly silent. We call this era the Cosmic Dark Ages, but even that name feels too active for the reality of this time. It was a stillness that lasted for hundreds of millions of years. If you were an observer floating in this epoch, you would feel a crushing sense of isolation. The sky is pitch black. There are no stars to guide you. There are no galaxies to break the monotony. There is only the endless, expanding ocean of hydrogen and helium gas. It is a solitude so absolute that it is difficult for the human mind to comprehend. In our modern world, we are never truly in the dark. There is always a distant city glow, the moon, or the faint band of the Milky Way. But here the darkness is total. Yet this silence is deceptive. While the universe appears dead to the eyes, it is very much alive to the forces of physics. In the dark, a great unseen architect is at work, building the scaffolding for everything that is to come. This architect is dark matter. We cannot talk about the birth of stars without talking about this ghostly substance. Dark matter is one of the great mysteries of modern science. We cannot see it. It does not glow, it does not reflect light, and it does not block light. It passes right through you as if you were made of air. But we know it is there because of its gravity. In fact, there is 5 times more dark matter in the universe than the normal matter we can touch and see. During the Dark Ages, dark matter is the ruler of the cosmos. Because it does not interact with light, it was not blown apart by the radiation of the Big Bang like the normal gas was. It was able to start clumping together much earlier. While the hot gas was still cooling, the dark matter was already forming a vast, invisible web across the universe. Imagine a giant spiderweb made of gravity, stretching across billions of light years. The strands of this web are thick filaments of dark matter, and where the strands cross, they form massive, heavy knots, deep gravitational wells. This invisible web is the skeleton of the universe. The normal gas, the hydrogen and helium, is merely the skin that drapes over it. As the universe cools, the gas begins to feel the pull of this skeleton. It starts to flow. Slowly, gently, the hydrogen atoms stop drifting aimlessly. They are caught in the current of gravity. They begin to stream toward the knots in the dark matter web. It is a cosmic drizzle of falling of gas into the deep pockets of the universe. This process is agonizingly slow. Gravity is the weakest force in nature. It takes eons to overcome the momentum of the expansion, but gravity has one great advantage. It only works in one direction. It only pulls. It never pushes away. It accumulates. As the millions of years tick by in the dark, the gas clouds in these gravitational wells grow heavier. They become denser, and, as any diver knows, when you go deep, the pressure rises. Deep inside these gathering clouds, buried in the heart of the darkness, the temperature begins to climb. The universe, which had cooled almost to absolute zero, is finding a new way to create heat. It is no longer the heat of creation. It is the heat of compression. The atoms are being squeezed together. They bounce off one another faster and faster. The thermal energy rises. The cloud begins to rotate, spinning slowly in the void. It fragments into smaller clumps, each one destined to become a solar system, though there are no planets yet, only giant balls of gas. We are now witnessing the gestation of the very first stars. Astronomers call them population 3 stars. They are the ancestors of us all, and they were monsters. In the modern universe, stars like our Sun are relatively small and polluted with heavy elements like carbon and iron. These heavy elements help clouds cool down, allowing them to fragment into smaller stars. But in the dark ages, the gas is pure. It is pristine hydrogen and helium. Without heavy elements to help cool the gas, the clouds have to be enormous before they can collapse under their own weight. So, the first stars are not like our Sun. They are titans. They are hundreds, perhaps thousands of times more massive than the Sun. They are colossal spheres of gas, spinning in the dark, growing hotter and tighter with every passing century. Let us move closer to one of these sleeping giants. We are deep inside a cloud of hydrogen, millions of light years from anywhere. The darkness here is thick and suffocating. The pressure is immense. The temperature at the core of the cloud has risen from near absolute zero to a few thousand degrees, then a few million. The hydrogen atoms are stripped of their electrons once again. The plasma returns, but this time it is not filling the universe. It is locked inside the womb of a protostar. The core becomes a pressure cooker. The gravity of 1,000,000 Earths is bearing down on a single point. The temperature crosses the critical threshold, 10 million degrees. And then, the magic happens. Deep in the crush of the core, 2 protons are pushed so close together that the strong nuclear force takes over. They snap together. They fuse. In that fusion, a tiny sliver of mass is lost, converted into pure energy. A spark is born. This spark does not vanish. It triggers the protons next to it. A chain reaction rips through the core of the giant. The nuclear engine ignites. The inward collapse of gravity is suddenly met by an explosive outward force, the pressure of light and heat. The star stabilizes. It pushes back against the dark. For the first time in hundreds of millions of years, a ray of light pierces the void. This is the cosmic dawn. It is not a gentle sunrise. These first stars are incredibly hot and incredibly bright. They burn with a ferocious blue-white intensity. They are millions of times brighter than our Sun. They are pouring out vast amounts of ultraviolet radiation, a screaming beam of energy tearing into the cold gas around them. Imagine standing on a dark, frozen plain, and suddenly a blinding spotlight is turned on. The light blasts outward, illuminating the swirling clouds of gas that gave birth to the star. It carves out a bubble in the nebula. One by one across the vast dark web of the universe, these lights flicker on. First one, then another, then clusters of them. The darkness is punctured by these beacons. The long night is ending. But these stars do something more than just shine. They change the universe itself. The ultraviolet light they emit is so powerful that it attacks the surrounding hydrogen gas. Remember the fog we spoke of earlier? The neutral hydrogen that shrouded the cosmos? The light from these first stars is energetic enough to strip the electrons right back off the atoms. It ionizes the gas. It burns a hole in the fog. Around every new star, a bubble of transparent, ionized plasma begins to grow. It is like a drop of clear water falling onto a foggy window pane. The bubble expands, eating away at the shroud of the dark ages. As more stars ignite, these bubbles grow larger. They merge. They overlap. This is the epoch of reionization. It is the second great clearing of the universe. The first stars are literally burning the fog away, re-sculpting the gas of the cosmos, making it transparent to ultraviolet light. They are transforming the medium of space from a cold, neutral gas back into a hot, charged plasma, but a plasma that is thin and diffuse, allowing us to see through it. However, there is a price to be paid for this brilliance. The first stars are doomed to a short life. Because they are so massive, they burn through their fuel with a gluttonous hunger. Our sun will burn for 10 billion years, pacing itself like a marathon runner, but a population 3 star is a sprinter. It lives for perhaps only a few million years, a blink of an eye in cosmic time. They live fast, they shine with a brilliance that defies description, and then they die in the most violent way possible. As we watch, the first of these titans runs out of fuel. The nuclear engine in the core falters. Gravity, which has been held at bay by the pressure of the light, instantly wins the tug of war. The star collapses in on itself. In a fraction of a second, the core is crushed down to incredible density. It bounces back. The star detonates, a hypernova. It is an explosion far more powerful than the supernova we see today. For a few weeks, this single dying star outshines the rest of its galaxy combined. It sends a shock wave ripping through the surrounding gas at a significant fraction of the speed of light. But this death is a gift. Inside the belly of that star, during its short life, alchemy has occurred. The hydrogen and helium were fused into heavier things: carbon, oxygen, nitrogen, iron, the ingredients of life, the ingredients of planets. When the star explodes, it does not just release light. It flings these new elements out into the void. It seeds the pristine gas clouds with dust. It pollutes the universe with complexity. The shock wave from the explosion travels outward, slamming into nearby clouds of gas. This squeeze triggers new collapse, new gravity wells, and new stars. The death of the first star becomes the midwife for the second generation. And this second generation is different because they have a sprinkle of that heavy dust, the carbon and the oxygen. They can cool down more efficiently. They do not need to be giants. They can be smaller. They can live longer. We are drifting away from the era of the monsters and moving toward the era of the galaxies. The universe is no longer a uniform sea of dark gas. It is becoming speckled with light. It is becoming chemically complex. The silence has been broken not just by light, but by the roar of the first explosions. The stillness is gone. The universe is churning. It is mixing. The great cosmic cycle of birth and death has begun. It is a profound realization that the calcium in your bones and the iron in your blood did not exist during the Big Bang. They were not there during the inflation. They were forged here in the dark, in the hearts of these short-lived giants, and then thrown across the sky to eventually find their way into the swirling cloud that became our solar system. We are the children of the cosmic dawn. We are the dust of the first light. As we reach the end of this dark era, the universe looks very different. It is no longer a smooth orange fog. It is a tapestry of black space, dotted with brilliant blue-white jewels. The bubbles of ionized gas are expanding, linking up, clearing the view. Gravity has done its work. It has taken the almost imperceptible ripples from the beginning of time and amplified them into blazing furnaces. The structure is visible now. The skeleton of dark matter is draped in jewels. But these stars are still lonely outposts. They are not yet organized into the majestic spirals and ellipses we see in our telescopes today. They are wild, chaotic clusters. They are the first tribes of the night sky, huddled together against the dark. To get from these scattered fires to the grand, swirling cities of stars that we call galaxies, we need one final act of assembly. We need to see how gravity sculpts chaos into order. We need to see the birth of structure on a grand scale. The lights are on. The stage is set. The actors have evolved from simple particles to complex nuclear engines. Now, the great dance of the galaxies must begin, so let us leave the dark ages behind. The dawn has broken. The sun is up, cosmically speaking. The universe is awake, and it is ready to build. We glide forward now, following the light, toward the era of galactic complexity, where the universe finally begins to look like home. We have arrived at the final leg of our journey across the deep time of the cosmos. We started in the quantum silence of the void, witnessed the explosive birth of space, and watched as the first stars flickered to life in the dark. Now, the universe is no longer a smooth, featureless fog. It is speckled with light. It is chemically changing, but it is still wild and disorganized. The grand structures that we admire in our telescopes, the majestic spirals, and the giant glowing spheres of galaxies, do not exist yet. To understand how the universe grew from a scattering of lonely stars into the magnificent cities of light we see today, we must look again to the hands of gravity. Gravity is the patient sculptor. It does not rush. It works over billions of years, gently pulling, nudging, and gathering. In the era following the cosmic dawn, the universe was filled with small, chaotic blobs of gas and stars. Astronomers call these proto-galaxies. They were not the elegant spinning disks we are familiar with. They were messy, irregular clumps. They looked like train wrecks of light and shadow. But gravity is a force of attraction. These small proto-galaxies felt the pull of their neighbors. They began to fall toward one another. Imagine a dance in the dark. Two of these small, glowing clouds drift closer. As they approach, their gravity reaches out and grabs the other. They begin to spiral. They swing around each other faster and faster, stripping streams of stars and gas from one another like ribbons. Eventually, they collide. This sounds violent, but in the vast emptiness of space, a galaxy collision is strangely ghostly. The stars within them are so far apart that they almost never hit each other. Instead, the two clouds pass through one another, stretch, turn, and eventually settle down into a single, larger shape. This process is known as the hierarchical model. It is a bottom-up way of building a universe. You start with small blocks, and you merge them to make bigger blocks. Over billions of years, these mergers happened again and again. The small blobs became medium-sized irregular galaxies. The medium galaxies merged to become giants. And as they grew, something wonderful happened to their shape. It is a principle of physics called the conservation of angular momentum. It is the same rule that makes a figure skater spin faster when she pulls her arms in. As the gas fell inward toward the center of these growing galaxies, it naturally began to spin. And as it spun, it flattened out. Just as a ball of pizza dough flattens into a disk when the chef spins it in the air, the chaotic blobs of gas flattened into vast rotating saucers. The spiral galaxy was born. These are the most beautiful structures in the cosmos. They are islands of order in the dark. If you could look down on one from above, you would see the glowing arms curving out from the center, traced with the blue light of young stars and the pink glow of nebulae. These arms are not solid structures. They are waves of density. They are traffic jams of stars, where the gas is squeezed just enough to trigger the birth of new suns. Our own home, the Milky Way, formed in exactly this way. It grew from the merger of smaller ancestors. It flattened into a thin, shimmering disk of stars, 100,000 light years across. It is a city of roughly 200 billion suns, slowly rotating in the void. But a city needs a center. And in the heart of almost every large galaxy, including our own, lies a monster. We believe that early in the formation of galaxies, vast amounts of gas were funneled into the very center. The density became infinite. The fabric of space-time ripped. A supermassive black hole was born. These are not the small black holes formed from dying stars. These are giants, millions or even billions of times the mass of the Sun. For a long time, we thought of them only as destroyers, eating anything that got too close. But now we understand they are also anchors. Their immense gravity helps to hold the galaxy together. They regulate the growth of the galaxy, breathing out jets of energy that stop the gas from cooling too fast, preventing the galaxy from using up all its fuel at once. They are the dark hearts of the galactic cities, ensuring that the lights stay on for billions of years. As the galaxies stabilized, the universe settled into a mature rhythm. The frantic activity of the early epochs slowed down. The rate of star formation peaked and then began a long, slow decline. The universe entered middle age. It became a place of steady, quiet evolution. And in the quiet suburbs of one of these spiral galaxies, in a nondescript arm of the Milky Way, far from the chaotic center, a cloud of gas began to collapse. This was about 4.6 billion years ago. The universe was already 9 billion years old. Generations of stars had already lived and died, enriching the cosmos with heavy elements. The cloud that was about to collapse was not made of the pristine hydrogen of the Big Bang. It was dirty. It was filled with dust. It contained oxygen, silicon, iron, and carbon. Something triggered it. Perhaps a shock wave from a nearby supernova gave it a gentle push. The cloud began to shrink. It spun. It flattened. In the center, the pressure rose until a yellow star ignited, our sun. But the story does not end with the star. Around the newborn sun, a disk of leftover dust and gas remained. It was the debris from the construction site. In this disk, the dust grains began to stick together. It started with the gentle force of static electricity, the same force that makes dust stick to your television screen. Tiny specks of carbon and silicon clumped together to form pebbles. The pebbles collided gently and stuck to form rocks. The rocks smashed together to form boulders. The boulders grew into mountains, and the mountains grew into worlds. It was a chaotic time. The early solar system was a shooting gallery of colliding rocks. But slowly, the winners emerged. The gas giants swept up the hydrogen and helium, in the outer reaches. In the inner reaches, where it was too hot for gas to settle, the rocky planets formed: Mercury, Venus, Earth, Mars. Let us focus on the third rock from the Sun. At first, it was a hellscape, molten, bombarded by asteroids, glowing red in the night. But the solar system quieted down. The bombardment slowed. The Earth began to cool. A crust of dark rock formed over the molten interior. And then the water arrived. It was delivered by icy comets and asteroids from the outer solar system, raining down on the young Earth for millions of years. The basins filled. The first oceans formed. We have traveled from the searing heat of the quark-gluon plasma to the cool blue water of a quiet ocean under a yellow sun. The universe has transformed from energy into landscape, and in that ocean, the most mysterious transition of all took place. We do not know exactly how it happened. It is perhaps the greatest remaining gap in our understanding. But somewhere in the warm, chemical-rich waters of the early Earth, the atoms learned to copy themselves. Carbon, hydrogen, oxygen, nitrogen. The stardust forged in the hearts of those ancient, dead stars came together in a specific pattern. They formed a molecule that could replicate. Biology was born. Life is the universe's way of getting complex. It is matter organizing itself to incredible levels of precision. Over billions of years, those simple single-celled organisms evolved. They learned to harvest the light of the sun. They released oxygen into the atmosphere. They crawled onto the land. They grew eyes to see the light that had traveled across the cosmos. And eventually, they grew brains capable of asking the question, "Where did I come from?" This is the profound circle of our journey. When you look up at the night sky, you are not just a separate observer looking at a distant show. You are the show. You are the universe. Every atom in your body was once floating in the primal fog of the dark ages. Every heavy element in your blood was forged in the supernova of a star that died before the Earth was born. The hydrogen in the water in your cells is 13.8 billion years old, a direct relic of the first few minutes of time. We are, as the astronomer Carl Sagan famously said, star stuff. We are the mechanism by which the universe knows itself. For billions of years, the universe was blind. It expanded in silence. It built stars and galaxies in the dark. But through the evolution of conscious life, the universe has opened its eyes. It can now look back at its own beginning. It can tell its own story. The journey from nothing to now is a journey of increasing connection. We started with a void that was teeming with potential but had no form. We moved to a uniform soup of particles. We separated into stars and galaxies. And now, on at least one small rock, that matter has woven itself into a web of consciousness that can appreciate the beauty of it all. As we lie here tonight, resting in the quiet dark of our own rooms, we can feel a deep sense of belonging. The darkness around you is not empty. It is the same darkness that cradled the first stars. The gravity holding you to your bed is the same force that holds the Milky Way together. The silence is the same silence that filled the deep epochs of the past. We often worry about the trivialities of our days, the schedules, the deadlines, the noise. But when we zoom out to the cosmic scale, those worries vanish. We are part of a majestic, slow-moving river of time. We are the current crest of a wave that started rolling 13.8 billion years ago. The universe is not finished. It is still evolving. Stars are still being born in the Orion Nebula. Galaxies are still colliding and merging. The expansion is still accelerating, carrying the distant galaxies away from us into the future. But for us, in this moment, the work is done. We are here. We are safe. We are the conscious witnesses of the cosmos, allowed to briefly open our eyes and marvel at the impossible grandeur of existence before we close them again in rest. Think back to where we started. The quantum vacuum, the bubbling foam of nothingness, the idea that everything we see is just a borrowed fluctuation, a temporary loan from the void. There is a comfort in that. It suggests that existence is a gift. We did not have to be here. The matter and antimatter could have annihilated completely. The universe could have collapsed back on itself. The stars could have failed to form. But against all odds, the fluctuation survived. The asymmetry won. The light broke through. So, as you drift off to sleep, let your mind float back through the stages we have visited. Float back past the blue skies of Earth, past the planets and the sun. Float out of the spiral arms of the Milky Way, drifting into the deep intergalactic dark. Watch the galaxies dissolve back into gas. Watch the stars wink out one by one, returning the universe to the velvet darkness of the cosmic dawn. Watch the gas glow brighter, turning orange, then white, as the atoms break apart. Watch the fog descend. Feel the heat rise, shrink down, smaller and smaller, past the era of the soup, past the era of inflation, until you are back at that single, tiny, vibrating point in the void, the point of infinite potential, the point of perfect balance. You are returning to the nothingness, but it is not a scary nothingness. It is the womb of creation. It is the quiet, peaceful state of potential from which all things arise and to which all things eventually return. The universe breathes out, and it is a cosmos of galaxies. The universe breathes in, and it is the silence of the void. Your breath matches the rhythm of the cosmos, slow, steady, peaceful. You are made of nothing but space, time, and starlight. And tonight, the starlight is resting. The energy that fueled the Big Bang is now the gentle rhythm of your own heart.